The first equation was between potassium and water. We had seen that it was the first thing we looked at. So those who failed the equation between potassium and water is that one that I have highlighted. We had it exactly in our notes. So potassium plus water, the products are potassium hydroxide plus hydrogen gas. Those are the products. The second equation was between magnesium and nitrogen. So for those who failed the product, we now go to group 2 elements. I mean chemical family of alkaline earth metals. So the second equation between magnesium and nitrogen was meant to be what I have highlighted. I think you can see it. We find it under alkaline earth metals. The third equation was between, before we look at the third equation, I think we can look at the fourth right away, because the fourth is magnesium nitride plus water. Remember we said magnesium nitride formed. Aida and Angel, can you mute your gadgets? We said that magnesium nitride that is formed is very important, because when this solid is dissolved in water, when the solid of magnesium nitride is dissolved in water, it forms ammonia gas. It forms ammonia gas. Ammonia gas is NH3 because the valence of nitrogen is 3 and the valence of hydrogen is 1. So the fourth equation was meant to be this, magnesium hydroxide plus ammonia as the products. Then in balancing, we had to put 6 on water, and we also had to put 3 on magnesium hydroxide. So that was the fourth equation, very simple. I wanted you only to complete. However, when you are completing equations, remember, any equation that is not balanced is not an equation. You have not done anything in chemistry if you write an equation and you forget to balance it. So the third equation was between sodium and oxygen. I told you when you were in senior one that this equation is going to appear the entire of your life. In every paper that you will do, every paper of chemistry, the reaction of sodium with oxygen, magnesium with oxygen, sodium with water, magnesium with steam, potassium with water, such common reactions. Can we always move with them, not only in our head, even on our fingertips? That is, there are some concepts which are very important and very common in chemistry. You can forget others, but how do you forget the reaction of sodium with oxygen? We burnt it together. I remember, I don't know if we did it in class or in the lab, but I remember we did that. And that day, I told you never to forget. So sodium plus oxygen, you realize I put in bracket that oxygen was in excess. The product is sodium peroxide, although some of your friends continued to put sodium oxide. The product is sodium peroxide. Just a quick one. Who can tell us the color of sodium peroxide? Baidi, I think this is your first lesson. What is the color of sodium peroxide? Baid, you are wasting our time.
Yellow.
It's
Eh?
yellow.
Who is talking? You are giving me chorus answers. Okay, thank you. The color of sodium peroxide is yellow, and the color of sodium oxide is white.
White.
Sodium oxide is white, and sodium peroxide is yellow. But for
Yellow.
both of them, the color of the frame is yellow. The color of the frame is a bright yellow frame, just in case they ask. So, still on equation 4, which was between magnesium nitride and water, equation 4, magnesium nitride and water, I asked just a simple question to find out if you know what you are doing. B part 1, name the liquid product. The liquid product is this one, which is in aqueous state, but we wanted you to name. So the name is magnesium hydroxide. And the gaseous product? The gaseous product is ammonia. Full stop. Simple as that. So from there, we should have gone to group 7 elements, and group 7 elements are halogens. The question is chlorine, just as they are here. I told you I don't ask questions outside what I have taught. In this particular lesson, you should pay attention. You can pass my assignment without even looking through the notes. Just you should have your book when you are attending a lesson. Have a book, a notebook, have a pen. When I say something is important, just note it down. You'll never be the same again. Chlorine, bromine, iodine, and fluorine. These are halogens, group 7 elements. So my first question was, state which one of the elements exists as a solid at room temperature. The answer is right here. The answer, I remember talking about it. They are colored, not what we want. Down the group, physical state changes. So the answer is on physical property number 2. Down the group, physical state changes from liquid to solid. Full stop in bracket. Fluorine and chlorine are gases at room temperature. Fluorine and chlorine are gases at room temperature. Did I ask for a gas? No. I asked for which one is a liquid and which one is a solid. So fluorine and chlorine are already out of the picture. Bromine is liquid and iodine is solid. Any more questions? The question is already answered. So, Amera, which one is solid at room temperature?
Iodine.
Good. Yes. Waguma, which one is liquid at room temperature? I think Waguma does not know how to unmute and answer. I want a boy to help him. Without wasting time, bromine is liquid at room
Mercury.
temperature. Give any two physical properties of the elements. The answer is here. They are colored. That is one physical property. Okay. Solubility in water decreases down the group. That is another property. Then if they don't mention whether physical properties, we said they are oxidizing agents. All of them, they are oxidizing agents. They exist as diatomic molecules. If we ask for something common in them, Give any two, write down an equation for the reaction that would take place when chlorine gas is dissolved in water. Reaction with water, the answer is right here. So when you fail these questions, you have ashamed me, you have ashamed your class, you have ashamed everyone who knows you. The equation is right here. Chlorine plus water, we said it forms a mixture of hypochlorous acid. Hypochlorous acid is this, and hydrochloric acid. And for that reason, I remember saying, let me see if the question is already there. To the resultant solution, this is the resultant solution. A blue litmus paper was added. State what was observed. We said the solution, this resultant solution, turns blue litmus paper red and then bleaches it. Bleaches it means to make it lose color. Make it lose color. I think we have always seen people who have bleached their faces, especially girls and women. You look at someone, you can't understand whether the color is brown. You see the face is brown, it is almost white, but the legs are very black. That means that person was bleaching from. So bleaching means you want to lose your initial color, your original color. So the chlorine, the chlorine solution will turn the blue litmus paper to red. And what is responsible for turning blue litmus paper red is hydrochloric acid, because it is an acid. All acids turn blue litmus paper to red. Then hypochlorous acid does the work of bleaching. Okay, that's the work of doing what? Bleaching. So what was observed? The answer is here. The solution turns blue litmus paper to red and then bleaches it. Chlorine gas was bubbled through a solution of sodium hydroxide. We talked about this. Chlorine plus sodium hydroxide. The products are sodium chloride plus sodium hypochlorite plus water. And we said the condition, this is only possible when sodium hydroxide solution is cold and dilute. So the observation, what your eyes will see, they will see a pale yellow solution. And what is pale yellow is sodium hypochlorite. Okay, sodium hypochlorite is the one that is pale yellow. However, if concentrated sodium hydroxide is used when it is hot, the product now becomes sodium chlorate instead of sodium hypochlorite. Now, I had to ask something on group 8. The notes are already here. Give a reason why group 8 elements are generally inert. The answer is here. Start from because. The word inert means very unreactive. Generally inert, that means they are unreactive. For someone to tell you that you are inert, it means I can come, I get a piece of glass, I put it in your eye, then you keep looking, keep standing like an electric pole. You don't do anything. So if someone says you are inert, that is the biggest insult. It means you can be insulted and you don't do anything, you do nothing. So they are generally inert, and their examples are here. Why are they inert? The reason is here. Their outermost energy levels. You see, in an atom, what reacts is an electron. So the electron that is always isolated, that is not paired, that is in the outermost energy level, is the one that reacts, that causes the reaction. And the reaction happens when that electron is either lost, when that electron is lost for metals, or when it gains an electron. When an atom loses that outermost electrons, or an atom gains an electron in the outermost shell, that's when a reaction takes place. So for group 8 elements, it means in the outermost energy level, they already have 8 electrons. And 8 electrons is the maximum number of electrons that an atom can have. So if it has the maximum or 8 electrons, then there will be no reaction. Okay? There will be no reaction because it is stable. Because to react means you have to add another electron. So that electron you want to add will be repelled because the atom already has 8 electrons in the outermost energy level. Or if it is to lose an electron, removing an electron from a stable energy level, it is a tug of war. So the group 8 elements do not react because their outermost energy levels are completely filled with electrons, making them very stable and unreactive. So the answer is right there. The outermost energy electrons, the outermost energy levels are fully filled with electrons. Someone can say they have 8 electrons in the outermost energy level, which is the maximum. Their outermost energy levels are fully filled with electrons. So they are very stable. Don't say they don't react because they are very stable. No, we shall ask you why they are stable. They are stable because their outermost energy levels are fully filled with electrons. Which group 8 element is used in bulbs, in light bulbs? These bulbs that provide light. I think you have ever noticed that when you accidentally drop a bulb down or you hit it, the way it breaks, there is something that is like bursting, and you see some white gas. I think you agree with me there. That gas is none other than argon. And the answer is here. Argon is filled in light bulbs to prevent the tungsten from reacting with air. So the gas in light bulbs is argon. Okay, any question from the assignment I had given you? You see, I'm trying to go slow. I want you to understand these concepts. You may not learn them again. Please. Any question? Nara. So I told you we shall be going to page 100, what? 114. Now, page 114, again, is something that is not new to us. What do we find there? Bonding. We are defining bonding as a chemical combination of atoms or elements to form compounds. Bonding is a chemical combination of atoms or elements to form a compound. The force of attraction holding atoms or elements together in a molecule is called a chemical bond. We have ionic stroke electrovalent bonding. We say this involves, we know ionic bond, ionic bond, we looked at it and said it is a bond that exists between a metal and a non-metal. And what we know about ionic bond again, what we know about metals, I want to ask you, no, let me tell you, metals lose electrons. And how do you know that an atom is a metal? For metals, they have 1, 2, 3 electrons in the outermost shell. Then non-metals, they have 5, 6, 7 electrons in the outermost shell. So in ionic bonding, we are saying it involves transfer of electrons from a metal atom to a non-metal. That is ionic bonding. Another name for ionic bonding is just electrovalent bonding. So it is the transfer of electrons from a metal atom to a non-metal, and it occurs between metals and non-metals. Then covalent bonding, for it we are saying it involves sharing of electrons between two atoms. And those two atoms must all be non-metals. That one we have been looking at it. I hope you are not lost. The only difference is that now we are looking at bonding in detail as a topic. Structure and bonding, we are looking at it in details as a what? A topic. So covalent bonding, this involves sharing of electrons between two or more metal atoms. The atoms and non-metals, and the atoms involved contribute to the bonding of electrons. We have a dative bond or coordinate bond. This involves sharing of the bonding electrons, which are donated by one molecule of the atom. This one we shall look at it in senior 5. Dative bond, it involves sharing of electrons, but those electrons that are shared are donated by only one atom. That is a dative bond. Then metallic bonding is a bond that is where we form a bond between only metals. That is metallic bonding. So let us now look at ionic bonding in detail. We already know something about ionic bond. We already know. I want you to write these key words in your notebook. We already know about ionic bonding. The first thing that we need to know is that it involves transfer of electrons from a metal to a non-metal. That is very important. Even if I ask you to define what an ionic bond is, you say it is a bond that involves transfer of electrons from a metal to a non-metal. The number of electrons lost by the metal atom are gained by the non-metal. The number of electrons lost by a metal atom or gained by a non-metal is equivalent to its valence. So when an atom loses 2 electrons, when a metal loses 2 electrons, it means its valence is 2. That's why the electrons in the outermost shell, we call them valence electrons. Those electrons help us to determine the valence. If you write, all of you write the electronic configuration of magnesium. Its atomic number is 12, so the configuration is 2 to 8 to 2. So for magnesium to react, it must lose those 2 electrons in the outermost shell. and the electrons lost determine the valence of magnesium. Yes. Now let us write the electronic configuration of chlorine, whose atomic number is 17. So the configuration will be 2 to 8 to 7. So for it to have 8 electrons in the outermost shell, then it should gain 1 electron. So the number of electrons gained is 1. So the valence of chlorine is 1. I think you get the point there. The loss of electrons from a metal atom leads to formation of a positively charged ion. This is not new to you. The loss of electrons from a metal atom leads to formation of a positively charged ion. So when an atom loses electrons, it forms a positive charge. When an atom loses electrons, it forms a positive charge. And the gain of electrons by a non-metal leads to formation of a negatively charged ion. This is again not new to you. The positively charged ion and the negatively charged ion attract each other. The positively charged ion and the negatively charged ion attract each other. From our primary knowledge, we remember what we said about bar magnets. Like poles repel, and like poles attract. So a positively charged ion attracts a negatively charged ion, and therefore there will be a force of attraction holding the two ions, oppositely charged ions, together, and the force of attraction is called an electrostatic force of attraction. So the force of attraction holding the oppositely charged ions together is called electrostatic force of attraction. So the compound formed is referred to as an ionic compound. Metal atoms lose electrons so as to gain stable electronic configuration, and non-metals gain electrons. Now, I want you to write this. It is not here. Write characteristics of compounds formed by ionic bonding. Characteristics of compounds formed by ionic bonding. We say they are soluble in water. Number 2, they conduct electricity in aqueous or molten state. They conduct electricity in aqueous or molten state. So compounds formed by ionic bonding conduct electricity. Then they have high boiling and melting points. They have high boiling and melting points. Okay, so those are some of the other characteristics. Let us look at formation of ionic compounds. We have been doing this. I think you don't have a problem with it. For example, we want to look at a compound that is formed between sodium and chlorine. The electronic configuration of sodium is here. 2 to 8 to 1, meaning sodium has 1 electron in the outermost shell, as you can see. So sodium is a metal, so in reaction it will lose that 1 electron. Chlorine, the electronic configuration is 2 to 8 to 7. So the electron lost by sodium will be gained by chlorine. And where does the electron go? Please, last time when we used it to do this work, we used it to make a mistake. This electron, you cannot put it here right now because it is just being transferred. The arrow shows that the electron is being transferred. So don't put it here as yet. But because when you put it here, it is a must. This atom will have gained that electron, so you must put a negative charge. So we put the electron this side, such that we put a negative charge here. These charges have been misplaced. This positive charge should be for sodium, and the negative charge should be for chlorine. I think you see that mistake. It is just a typing error. Okay, stop writing on my screen before I remove you. So the sodium that loses the 1 electron in the outermost shell, for it, it will remain with the 2 shells. This is the first one, as you can see, it is here, and this is the second one. It is also there. But the other outermost electron, which contained 1 electron, the outermost shell that contained 1 electron, the electron has been lost, so the shell is empty. And when that electron is lost, then the sodium atom will gain a positive charge. So it is no longer now sodium atom you are seeing here. It is now sodium ion with a positive charge. This one is now sodium ion with a positive charge because it lost the electron. Then that electron that was lost, originally chlorine, the outermost shell had 7 electrons, 2 plus 2 plus 2 plus 1. But now you can see there are 8. So the chlorine atom gained that electron that was lost by sodium. So it now also has a negative charge. And we are saying these oppositively charged ion atoms attract each other and they form a compound. Now the compound will have no charge because positive 1 plus negative 1 is equal to 0. That is sodium what? Chloride. I want us to study this example now of magnesium oxide. Now, in magnesium oxide, magnesium, this is its. Remember, we can tell you to use only valence electrons, the outermost electrons. Then you only draw the outermost electrons. Okay? Inside, you just put the symbol of magnesium. Even here, you just put the symbol of magnesium. So when magnesium loses these 2 electrons in the outermost shell, the electrons will be gained by oxygen. The electrons will be gained by oxygen, which has 2 electrons that are not paired. So you realize oxygen needs 2 electrons such that it gets 8 in the outermost shell. And magnesium, for it needs to lose them such that the other outermost shell is off and it remains with 8. So atoms only struggle to have 8 electrons in the outermost shell. So magnesium that loses the 2 electrons will become positively charged, and oxygen that gains 2 electrons will have 2 negative charges. And the symbol is there, magnesium oxide. So the 2 oppositely charged ions will attract each other like that. And the formula will be magnesium oxide. Now, There are cases like this one where calcium is combining with chlorine, but one chlorine atom needs to gain one electron. Chlorine atom needs to gain one electron, whereas calcium needs to lose 2 electrons. So in that case, you add another shell of chlorine. You add another atom of chlorine such that they become 2 to cater for all the electrons that are going to be lost by calcium. And calcium loses 2, you get 2 positive charges. But now these will be 2 chlorine atoms when each atom has gained 1 electron, so it will have a negative charge. So there will be 2 chlorine atoms with each one having 1 negative charge. So we had done this work, we are just reminding ourselves. So we can stop there for today, such that I give you some simple work. Any question? Who has a quick question?